You hit click, and before you can blink, a full web page materializes on your screen. No waiting, no friction. Because we use terms like the cloud and Wi-Fi, it's easy to imagine your data floating through the air or bouncing off satellites orbiting in space. But that invisible cloud is a myth. The internet is heavy. It is a massive, completely physical machine built from copper, glass, and steel. That single tap on your screen forces thousands of mechanical components across the globe to execute millions of operations. To understand how this global structure actually functions, we have to freeze time and track the exact physical journey of a single click. The moment you request a website, your device asks the Domain Name System, or DNS, to translate the web address you typed into a numerical IP address. But your device doesn't request the website as one giant file. Instead, it shatters the data into tiny pieces called packets. Through TCP/IP, each packet gets its own instructions: the source IP, the destination IP, and a sliver of the actual payload. Breaking the information down like this means the pieces can move independently. They don't have to follow each other in a straight line. This constant fracturing keeps all the data fluid. If a network gets congested, packets simply scatter, taking completely different routes to bypass the traffic. These fractured packets leave your device, hit your local internet service provider, and immediately dive underground into the global backbone network. Over 90% of the world's data travels as pulses of light, shooting through physical fiber optic cables buried under the dirt in your neighborhood. To connect continents, massive industrial ships spool thousands of miles of these lines directly across the floors of the world's oceans. At major intersections along these cables, the packets hit routers. These machines act as the traffic cops and the navigational brains of the internet. This animation shows how routers constantly calculate the fastest path. If an underwater cable gets severed by a ship's anchor, the routers instantly detour the packets down alternate lines. Because the network can physically self-heal and route around damage in milliseconds, taking the entire internet offline is practically impossible. As these packets speed through cables, most are locked behind security layers like HTTPS encryption, guarded by firewalls to block unauthorized access. But the transit infrastructure itself is always watching. Your internet provider, your browser cookies, and public search engines continuously monitor exactly where your packets are going, building profiles to target you with advertising. People often buy virtual private networks, or VPNs, to hide their IP addresses and encrypt their traffic. But the moment you reach a website and log into a personal account, you willingly reveal your identity. Total anonymity on the standard web is largely an illusion. The infrastructure is built to route your requests, which means it inherently knows who is asking. And finally, thousands of miles away, the packets reach their destination server, a physical machine sitting in a humming data center. The packets arrive, read their instructions, and reassemble perfectly to render your web page. Chances are the specific server you just reached is part of the deep web. That term sounds intimidating, but it simply refers to any data hidden behind a login screen, like your banking portal or private emails. That is completely different from the dark web, which makes up only a tiny fraction of global traffic and requires specialized browsers to access. Public search engines like Google only index the surface layer. The vast majority of the internet consists of unsearchable deep web infrastructure, a global machine spanning ocean floors, built of buried glass cables and self-healing data. All of it sitting perfectly still until you hit click.